Hello, welcome to this behind-the-scenes video series which documents the design process of a Eurorack module. This is the module itself in question, the tràigh transistor ladder low-pass filter, which I originally designed as the second module that I launched as Instruō back in 2016. So this is the original here, but I revisited recently for this project. I'm actually joined on camera during the bulk of this project by David, he helps me run things behind the scenes here at Instruō. We spent a Saturday in the workshop just working through the schematic capture process. Ended up being somewhere between a sort of circuit design tutorial and some sort of video podcast episode of us just generally talking nonsense. And there's a project overview video which I'll link to below. That kind of explains a bit more the background to this project. The series itself is very much long form, so there's a lot of time lapse sections. This is warts and all, so this definitely includes a lot of mistakes that I made through the process, PCB iterations occurring because of that. But yeah, I tried to capture this comprehensively to show more of an overview, like a realistic example of the design process for a module. Yeah, Instruō very much started out as a media project where it was less about the final designed result and it was more I wanted to capture and depict the design process. So it was time-lapse capture of schematic, PCB tracing, assembly, testing of the original tràigh module. So it's a format of content I've been quite keen to revisit, and this tràigh module project it gave me an opportunity, I think, to try this out again. So thank you for watching. Hope you enjoy. We are live. Do not swear. Okay, the challenge for today is to speedrun and recreate the tràigh, which started off as that. Is that on camera? It's on camera. Cool. That's the original one that's in. Actually, it got a full build video the same as the tràigh did.
Oh yeah.
Didn't do as well as the tràigh video.
Were they designed together to function together, or did you design the tràigh and then?
Tràigh followed it, and I kept the reference. It being the Minimoog low-pass filter,
right?
It had its 3 inputs anyway, so I think a lot of the reference schematics that I studied, like they kept that. This is the original tràigh. That's the tràigh video. I went a bit glitchy with the video, which people didn't seem to like. But whatever.
Didn't like?
No.
Oh.
It's had some views. Yeah, I thought that bit was quite interesting. So that's the actual, starting with the tràigh layout and trying to figure out the interface. So that was kind of a first, after having like a reference point of the tràigh for where the knobs are. So
like how would this interface pair with another
and
interface?
Like how on grid do I want to be? How much do I want to retain certain patterns and dimensions? So a lot of it was trying to find shapes. It's a little bit glitchy. I used to carve all the traces just because it looked cool. So that was the first test, and I used completely the wrong capacitors on it in terms of type of capacitors, so they were all ceramics. So I didn't realize this until much later on, plugging it in or like changing the system a bit. If you just tap the back, they're all ceramics, but this was before C0G types, which is a more modern type of ceramic cap that have really good spec, like comparable or better than film caps, which are typically the go-to for audio signal paths. So the production one I put threw all film caps on, which are missing on this. It was all the WEMA red caps on it. So yeah, this number got a revision to change to COGs because it got discontinued because I ran out of this chip, which is tràigh. There we are. So any of the transistors that are that shape, they're part of an IC, which is LM303046. So that was a matched transistor pair of just BJT transistors, I think. Yeah, they're all discontinued. I didn't know if that was the full part number. I basically bought the rest of the stock that was at Mauser, so they're out of stock because of me. But yeah, I just stockpiled them, got these mostly pre-popped, and then all the transistor ICs were put on by hand. I think it's 5 matched transistors in a single chip or something like that. But the circuit reference I looked at, it was using some other 857s and 847s. So I think what I did for a revision of this, because this was discontinued because the parts ran out, but I revised it with the ARA, so it's the same filter circuit. But I'm going to go back to simpler form, so this is more passive for how the resonance ties in.
Right.
I was checking with Noah to see if he had any suggestions for any improvements. I think I kind of improved on the ARA circuit because I had I branched out the feedback source from another path, and it was going through a VCA, so it was digital controlled over the resonance level, and that's summed in here, which is the input mixer stage. So the feedback was directly to the input, whereas this more traditional reference, that I copied. Like me and Noah were trying to figure out why that's got such a positive offset. I guess because it's AC coupling with a polarized electrolytic capacitor, so they need to be positive charged on one side to operate properly. So it's pulled up to 12 volts, and then that same 12 volts has got another 1K to pull up this other source. So that's the output source out of the filter, and then buffered with an op amp. But that's a branch of it, AC coupled, and it's not even attenuated, so that's a C50K, so that's an anti-log tapered pot that's used. I'm going to put that to higher resolution, don't know why it's so blurry. That's better. So as you turn the pot clockwise, you're moving the taper towards pin 3, so you're reducing the resistance of it. So I guess that acts as a variable voltage divider at this stage,
right?
Kind of, although that's AC coupled as well. So I guess it's just changing the impedance level, and it punches it in on that side of that rung of the transistor ladder, sort of opposite the input stage. Yeah, it means no CV control over the resonance, which I'm going to keep for this revision. But there is an addition I'm planning to make to this, which I patched up downstairs the other day. So that is taking a branch of the input jack. So whatever audio rate signal or whatever waveform is going in here is going to branch off to a frequency divider, so a CMOS flip-flop, and the output of that will normal to this jack. Same thing, the normal of that jack will connect to a second flip-flop going to this one. So if you patch an audio signal in here, you get sub-octave as a square wave, you can then mix in, and then a sub-octave of that, so 2 levels of sub, which sounds really fat.
Cool. So if you patch into the second one, do you get a sub in the third?
Yes.
Yep.
Yeah. Or if you patch in here, you'll have a sub of that signal. If you patch in here, it breaks the normal. So if you patch discrete signals in, you're bypassing the frequency dividers, but it cascades from left to right, is the plan.
Cool. Fat.
And layout-wise, I'm going to keep the interface the same. The circuitry is going to be a complete redo. Forgot I did shots like that.
Sort of horror movie shots.
It's quite horror movie shots. I must have been watching The Evil Dead quite a lot. Yeah, definitely watching The Evil Dead quite a lot. It's kind of overkill, but whatever. Thank you for watching. Yeah, so it got a full video way back. I don't think the Troika went into production through Dark Place Manufacturing, so that happened there. I think Tràigh I just kept as a small batch initially, and just put out on social medias and like just did a few hand builds. It wasn't until later on that we were. Yeah, it was an earlier design, but then the harmony kind of came after that. But that kind of got momentum going a bit more as things started scaling up. So I kind of went back to the Tràigh, and that got added it back into the range at a certain point.
Kind of relaunch.
Yeah. So what do I need to do to set this up? This is going from scratch. So this is a new project completely. So I'm going to go to GitHub and set up a new repo.
Were you already using KiCad when you did the Octone video, or was that Eagle?
No, that's Eagle.
So this is your first.
This is the first. I did screen record and stuff. I full like video recorded the redraw of the dial, because that had an extra, arguably needless revision. Now there were a few things changed, so it was definitely improved. But I redrew the whole thing in KiCad,
right?
Because I'd done the toner as a first KiCad test, and yeah, decided to get it up to speed because I really like the dials. There's plans for expansion, stuff like that. So if it's all in KiCad, then it's a bit easier to translate and expand upon. Okay, I'm going to call this repo Try Again. There you go, that's available. Winston. Oh, I can do the O with a little dash. There we go.
Does your repo name have to be entirely unique? Or is it just unique to your username?
I think unique to my username, right? Because it kind of becomes a URL.
Yeah.
Winston fundraiser module. Private repo, just for me. Gitignore, I'll add the KiCad gitignore. So gitignore, that's just a template for what files in the repository don't synchronize to the version control and stuff. Otherwise you end up with lots and lots and lots of duplicates. If there's like temporary files that get added in during saving or anything that's like stuff in RAM, then it doesn't get saved time and again. License, none.
So see when you went to add gitignore, can you show me that drop down?
There's loads of things you can just right. It's got a ton of options. So KiCad's one of them.
Cool.
I don't know if there's like an equivalent for Eagle. No, there is. I assume that's the same Eagle. Eagle just seems quite a generic bird to name your CAD program after.
Yeah.
Create repo.
Eagles are so passé.
Okay, so let's do this, and I'm going to clone this to my main project directory. Okay, git clone. Oh, how I put the URL in. Git clone there. cd try again. And there should be nothing in that directory other than the gitignore file and the readme. Nope, nothing at all. Did I not set it to put a readme in? Oh, I must not. Add readme. Hello. Okay, so there's git ignore and readme.md. Git pull. There we go. Added the readme. So now we see this here. I need to modify the KiCad git ignore because there are some extra things that is a bit more Instruō specific just for how we do the library stuff. So first thing, I need to clone the KiCad library repo that me and Noah have been working away on.
That git ignore is not shown up in your Finder because of that dot that's in front of it, right?
Yeah,
It's a hidden file.
so it's Command Shift dot, and that shows hidden files in a Finder directory. Yeah, so this is libkicad instro. So this is our constantly evolving GitHub repo. So what we do is we just clone that as a sub-repo inside project repo. Me and Cian did look through the git submodule method, and just the way that KiCad is a little bit finicky with its libraries, it didn't work quite as well as we were hoping. So we've kept it as a manually done thing. I mean, at some point I'll write a bash script that will like automate all this. It would just be like new project, give it the name, and then it does all this. But it's not easy to install. Yeah. So I'm currently there. So so that's cloning the library in. This will be the most up-to-date one. What's the last project I was working on? I guess it'll be Glock. Shift dot. So I'm just going to copy the extra bits from the git ignore of the Glock project because I know it's got what I need. Just pull up a text editor. I don't know why Sublime Text always just opens in a random desktop tab that you're never in. It never just opens it. And I don't know why. Okay, so this is an older reference one. So if I go to try again, git ignore, add those lines, save, done. And then I can push this as an initial commit. So git ignores there, and the git ignore should ignore that library folder. So it's a bit of juice. Like if I need to modify a part, we're trying to keep things global so that it's always modifications or iterations on the main global library. So it means that I need to change to the actual original repo of that and update the project there, push that, and then go back to the working project sub-repo and pull that. Yeah, I don't know if this is the best way of doing it or not, but it's working so far. Add dot git commit sm initial project commit push. There we go. Now let's set up a new KiCad project. KiCad. Let's go new project. Let's save it here. And we'll call this tràigh. I'll just call it try within the folder. So the repo is try again, but I'll just refer to it as try again. Underscore hardware. Let's do that. And we have new project. So what I do need to do is add the local libraries to it. So manage symbol libraries. These should have nothing in it because it's a fresh project. So this is just the stock KiCad libraries, which I tend not to use. We're trying to just get used to using our own footprints, because that way we know, we build up a checklist of which ones are tried and tested. So this I need to open up here. This is symbols. So symbols, and it's any that's the .keycad's SYM is they're kind of categorized. So we've got analog ICs, digital ICs, mechanical, passives, semiconductors, and then JSON and then NOE. So it means that if I'm adding any new symbols, so that's me just drag them to the symbol editor in KiCad, and each one's going to ask if I want this to be defined globally or per project. So I'll keep it per project for each one. And it's somehow remembered to star them so they always appear at the top. So that's analog ICs, which is some CMOS stuff. It's kind of just a short list of the most regularly used ones we have. Digital, we've got DACs, we've got shift registers, some processors, mechanicals, connectors, and PCB joins, jacks, semiconductors, and then my one's just gradually filling up with a lot of duplicates of STMs, because we're going through different pin iterations and stuff. So,
right.
I've finally got into a habit of like tagging what date these were done as. But yeah, a lot of them are things that get added. At certain points, me and Noah will have a day where we just go through and blitz and then move these to the most appropriate like subcategory. But
it means like the master version of it and then update the GitHub.
Exactly, yeah, because Noah's got access to, he's a collaborator on the main library repo as well, and we've got a folder each. So if Noah's adding a device, he only adds it to the Noah folder. So we can add, commit and push to the repo, but only, we're just setting the rule that we only do that within our own user folder, because that way it doesn't create any conflicts. It means that we can be working on essentially different branches and pushing additional stuff, but it's never going to conflict by pushing to the same location. So it means that anytime I'm pushing stuff, if I do a pull, it will just update anything that Noah's added in between. So that's the symbols. Same thing for the footprint editor, because KiCad has a differentiation between schematic symbols and footprints, and the linking's done in the project. It's not done in the library, which is quite different from Eagle.
Right.
Which took a bit of getting used to. And I like their naming scheme. So all the footprints are in individual folders. So we've got the same thing. We've got ICs, mechanicals, passives, semiconductors, and then a JSON and NOE. And they're all folders that are named .pretty.
Oh, that's nice.
I don't know why it's .pretty. There'll be some historic reason with KiCad, I assume. I think they're all in the project, so that's there. And that's a set. So what I'm going to do is just redraw the schematic afresh in KiCad. I'll probably add the components as I go in terms of footprint mapping. I've lost my pinch to zoom gesture. There we go. This is why I have a massive screen, so I can see everything. Cool, let's dive in. So yeah, I don't think I've done a proper tutorial like I did previously in Eagle on that. The setup here, this is the project, the KiCad project, where it's got this schematic file and board file, and then if you add other sub-schematics, they just like appear in this directory. But yeah, these are linked. So if I add something in it and go to the board file, I need to do a command that updates and compares to the schematic, but it's assuming the schematic has a symbol part with an associated footprint already defined. I think there are different approaches that people do, where sometimes it's done completely isolated. You capture your schematic and populate that, and then do a pass where you go through and assign footprints to all the components at once at the end.
That sounds horrible to me. I think I'm just never used to doing that process.
So you link them as you go?
Yeah. A lot of the parts I've got, if it's just passives or jacks, then I've got a default one that I use. So capacitors, most of the time if I'm adding ceramic capacitors, I'm using 0603. If I add a resistor, it's 0402 normally. And then things like the ICs, so TL074, it's the TSOP package version. I've not figured out how to associate all the other ones in the Instruō libraries yet. Like, this has picked out different packages that are associated with this number of pins that are just across the whole KiCad library. Yeah, there's a few things I'm still figuring out, but yeah, it's working well enough at the moment. So let's have a quick look through this, because we need to figure out what ICs there are. Looking at this, there are two larger SOICs, so that's 1, 2, 3, 4, 5, 6, 7. So 2 SOIC 14s. Those are the now obsolete transistor ICs. The only other IC is that guy there, which is TL072. So that's our input buffer, which is just an inverting summer. So that's the mixer input. So that's the 3 faders, 3 input jacks, summing stage, and then the last one is output buffer, just for setting a better impedance at the output. So that's on this version, because I'm going to go discrete for all the transistors, that will be the only IC. So I just need to add a single TL072. I guess I've got the option of going SOIC or TSOP. There'll be plenty of space, but I want to ensure that I'm getting all the components topside. So I'll probably go with the smaller footprint versions as I can. So adding them in, that's automatically named them as U1, A and B for the two parts. Although where's the power for these? Okay. Symbol unit. Maybe I just didn't click enough times. 1, 2. There we go. So there's 3 symbols for this.
Right.
1 op-amp channel, 2 op-amp channels, and then the power stage. What I'll do here, I'll start already by creating a subsheet, because I'll have a sheet that is for power. So S draws a sheet, and it draws it in a box.
Right.
Power, and then I'll just name this the actual file itself the same. Power. I like filling the background with a color so it looks kind of like a.
So what is a sheet?
It's another file. So if I go back here, it's not showing anything.
It's like a sub schematic.
Yes. Yeah.
Right.
Yeah. Where's my Finder directory? Try again. Hardware. There. Power.keycad.schematic. So that's a self-contained schematic symbol, but the main project schematic, if I have a box drawn that is a sheet link, then I double click on that and it opens this subsheet.
Okay.
I mean, there's tricks as well where I can add inlet input, and this could be a source going somewhere. If I step out of it, edit sheets, import sheet pin, I can show an inlet on this. So it means that from this upper level sheet, I can send something in there. And if I highlight that, enter the sheet. This maybe needs to connect to something else. I can't remember how it names it. I think it depends on if I name this as a specific net class or something, then it will hold continuity and show me in between. So.
Right.
But it's just quite a nice way to to keep things organised.
Yeah.
Let's just add the power section here. So that will be 2x5 pin header and diodes, ferrite beads, capacitors. So let's go with mechanical. 2x10 connector, 10 pin. Oh, Eurorack power 2x5. So I've got one that's the shrouded header footprint. So I'll just go with that because I don't need to put a shrouded header on it if I don't want. It's got my hand-drawn lightning bolt as well because lightning bolts are cool. So that I need a diode. The diode that I use for polarity correction is this guy. So positive, I want to go anode to cathode from the source. For negative, I'm going to flip it and go anode to cathode going to the negative. Start drawing these. Actually, what I will do at this stage is where did I define the settings? I've still only done this a handful of times, so I'm still getting used to the whole process. Preferences in there.
You can edit this out.
Yeah. Chasing rabbits. No, this must be in the schematic side of things. Net classes. Oh, here we are. Import settings from another project. What's going to be comparable to this? What other projects have I done that are keycard? The dial is quite substantial. I'll go with dial. So I'm just going to import the sort of project settings from the dial, which had a few like things that I'd figured out at that stage that is a bit finicky to rebuild from scratch. So let's go with that. Open. Forward to preferences. Net classes. Let's just go net classes just now. So that's adding in a wide range of power supplies, although apparently I named a power line George in the dial. I do vaguely remember that. I think I just needed something to be recognised as a power net class, and it wasn't necessarily, it was like a variable, but yeah, so I just called it George.
Yeah, it's inoffensive.
So it's basically set up two fundamental net classes. There's power and default. So any other traces defaults and power specifically. So this means when it comes to drawing and routing the boards, I can just set a predefined thicker trace width for power versus everything else. I mean, you can get really meticulous and have different looks in the schematic for different power lines. I just keep them all looking the same. Yeah. So diodes, then add ferrite beads.
Does that thickness refer to the actual thickness when it comes to fabrication, or just in the way you're visualizing it?
Just visualizing it in the schematic at the moment. But the thickness of the trace is another parameter you can set within the
net class.
Within the net class, and that applies to the PCB layout. Right. So ferrite beads, they're little 0603 doodads. That looks like. No, that's a symbol there. So how do I? So it's set to an 0603 footprint. So ferrite beads are like the little beads that you get on like longer USB cables, stuff like that. It's literally just a magnet.
Yeah, it's like in a little cylinder near the power.
So these are that, but in. I don't even have it on that. Have anything that has a ferrite bead in it? Maybe somewhere. They just look like surface mount capacitors, and it is just a conductor surrounded by a magnet. So it removes a lot of high frequency interference and stuff. So it's kind of like a basic passive filter for noise on the power line, which the tràigh definitely needs, because the tràigh is a particularly sensitive circuit. Ground. Okay. So that's my ground defined. Buzz. Then bypass capacitors. So this for power, I'm going to go with at least 10U, so 10 microfarads. So that I'll go with a larger footprint, which I'll need to figure out how to find that. I'll just add the default, which will be 0603. These will be 3 round. Value 10U. Oh, that's a capital U, don't want that. So these are a bunch of key commands that I've now sort of built into muscle memory. So if I highlight something, V brings up the editor for value. Yes, I've got that.
Yeah. There's a masterclass going on downstairs.
10UF. Let's do. Okay, so if I do E for symbol properties,
okay,
that's what E is short for, I guess. I can go to the footprint. So this is where it's the definition for the footprint for this particular symbol. So
right.
This is where it's pulled me through to the footprint library selection, and all the Instruō bits are at the top. So I'm going to go down to 1206, which is just a larger surface mount capacitor footprint. So those are 12. I'll just copy that. And let's do this and this. Connect them. Draw this out, and that is ground. And these are my power rails, so positive 12, minus 12. So to add that, I'm going to add plus 12 volts. So that's adding a symbol part, which if I connect that to a net, it now defines this net as 12 volts,
right,
and applies it to the power supply net class. Although it doesn't always do that natively, so sometimes you need to go to this, which is choose power symbol and power flag. So sometimes this is needed just as a way of quickly forcing recognition that it's a power. It's a power trace, which I'll actually need to, because these are all power traces, but that's plus 12. That is plus 12, which is before the ferrite bead, and that's plus 12 between the actual pin source and the diode. It doesn't necessarily realize that they're power flags, power traces. So I'm just going to stick a flag at each of these points.
And so, what is the purpose of flagging them?
So when I set up here and I've got default and I've got power, when we're in the board file, I have a different thickness defined. So I can go to, there's an equivalent setup page on the board file where I can select the dedicated thickness of wires and spacing concerns, what size of via. So a lot of parameters for that I would probably want for a thicker trace for a power line versus a signal line. Right.
So power flag is it's a flag to the net class.
Yeah. I think so. That's what it's. I've just started doing this preemptively more because a lot of the times when I'm doing the design rules check, it flags up an error because it's saying you've connected something to a power pin, but it's not a power net. Right. So it means that just adding that removes that error. So add a negative 12 volts. Stick that there. Oops. That's now negative 12. I think that's kind of all we actually need on our power schematic, because there's no regulators. It's a pretty small circuit. So put that there. Actually, that's what I'll do. Any ICs that have a power section, I can just copy that into this subfolder, and it means that if it's still named U1, C being the third symbol thing, so that's symbol A, B, and then C's on the other one. So that's still one part within the project's global schematic, but I've been able to move that here, so I've got all my power stuff in one place.
Right.
And what I'm going to do ahead of time now is just add in some bypass caps that I would want on an IC. So this is going to be bypassing to ground. So it's kind of like a local, like if it's pushing and pulling current, then there's a local, just little buffer there. Or that's probably completely terrible terminology to describe as. It's how I think of it. So I'll change the value to 100 nano and change it to 603. I'll just do that. Oh, this is another detail in KiCad that took a bit of getting used to, but I'm now fully used to it. If I want to like select a group of stuff, then I can hold Command and click on other stuff, and it will like just add that to the group selection. I think Shift also works as that. If I want to drag and select stuff, if I drag like that, it's selecting only the things that are close by. Is it that? There's a difference between dragging left to right and right to left. Like dragging left to right selects things in a different way. There, that's an example there. So if I drag right to left here, I've not selected the whole thing. It's just
the text.
Yeah. It's like more of a micromanaging type level of selection. But if I drag left to right and just capture a bit of that, it's captured the full capacitor.
Interesting.
It's weird, but it's like strangely intuitive once I'd sort of realised that was a differentiation. So it means that if I'm selecting a bunch of stuff,
it's useful to have that differentiation as long as you know that it has it.
So if I do that, if I drag left to right, and I'm capturing, it looks like I'm touching the capacitors, but it's only selected anything up to there. Whereas if I go the other way round, that selected the capacitor, so it selects the full thing, versus that. And so here, if I'm almost covering the whole thing, it's not actually captured everything.
So if you go from left to right, it's more pedantic.
If
you go right to left, it's like, I know what you mean.
It's weird, and it's kind of just been getting used to it by feel, almost. Okay, so I've rambled, and we've got a power section and an op amp pair. That's okay going, I guess.
See the final like buffer stage that you were putting in the power section, is that related to noise reduction as well? Those final capacitors that you put in on the right?
These ones or these ones?
Those ones.
So these are the bypass caps that I'll put as close to the op amp IC as I can. If it was a circuit that had more ICs, it had more op amps, then I would want like anything that is pulling from plus minus rails, I would want a pair of the 100 nano caps at it. So that's kind of in the spec sheet for most capacitors. They'll say put a 100 nano capacitor as close to the power pin as possible. It's so standard that you kind of just expect that to be the requirement for pretty much any IC.
Right, and is that just to protect the IC?
It's kind of a noise reduction, or just like because if an IC is going from inactivity to suddenly having to like, if it's an op amp, if it's going from 0 volts to a big voltage spike, then it's basically reading an input with theoretical high impedance. So it's not actually the source signal is being buffered and recreated. It's being like cloned so that it's got its own localized power source, which is there. But it means that the op amp's going to go from idling to immediately having to drive a current. So it's going to pull from the rails suddenly. So it means that if there's a capacitor there, it pulls from that capacitor. I mean, water's kind of the best analogy. If you've got like a dripping tap and then a jug, and if you need to like fill a cup, then it would take a while to fill it, or you would need to like create a vacuum and pull from it, which is going to weaken the power of that pipe source going elsewhere. Got you.
So it's kind of like a reserve almost.
Exactly. Yeah. It's like what's going on?
Yeah, and it stops it interfering with other parts of the circuit.
Yeah. Okay. I guess the macro analogy is like home batteries. That and there's some companies, I think Tesla were doing it for a bit, where you could get like a home battery for your house that could charge from solar or something like that. But they're not a bad idea if every house had that, because there's the whole issue with UK power stations where come like 4 o'clock or whatever it was, when
the commercial break in Coronation Street.
Exactly, yeah. They had to time it so that the grid was given more juice because everyone was turning their kettles on at the same time. Whereas if everyone had like a local capacitor at their house, then it wouldn't tax the main grid as
much. Or
a
T-urn.
Yeah. Everyone should just have a constant T-urn. That would solve it. So the capacitors are that on a micro scale. It's probably, if anyone that's an engineer that is watching any version of this that makes it onto the internet, they're probably cringing at horrific analogies and incorrect descriptions of circuitry.
Well,
I don't know. I
never can make their own video.
Yeah. I didn't study any of this nonsense. Let's build through in chunks. So I'm going to do the input buffer stage. So I'll build this out. I'll add the jacks. So that is passives. Not passives, mechanical. Jacks are mechanical? Jacks are mechanical. Here we go. Oops. Mono 3.5mm. That's the one. And let's just name these as we go through. Value. So this is AN1. And it should have, so this is something I might change as we get into the PCB layout. Like the standard ones I use have got the ground pin kind of smooshed in at the side, because it fits and holds a bit more naturally. But sometimes I might want that on the left or the right, so I'll just keep it to S1 version for that to start with.
Is that your own edit of those footprints?
Yeah. I recreated the like silkscreen patterns from the versions that I used for years in Eagle. I did the same for like a lot of the ICs, just because seeing a silkscreen that's unfamiliar was like, oh, I don't know what that is. So here, add a ground. What I would normally do for an input jack is tie the normal to ground, so that when nothing's patched in, it forces that to be a ground reference. Depends on the circuit. If it was a non-inverting buffer, where that was just connected straight to the tip. It would mean that if nothing was patched in, like an input buffer stage would just be floating. So this would help terminate it if nothing was physically patched. I'm going to be using the normal jack for input 2 and 3. So I'll keep this like that to start with. And let's start adding potentiometers and resistors and stuff. So pots. I can't remember how I've done potentiometers for schematics. It must be in mechanical as well. Nope. Passive? Passive, here we are, rotary potentiometer. So, whoops. Slide potentiometer, that's the one. Okay, and we want 20mm faders for each one. So, I'll change this once I've applied it. So, that's it. There, it also has an LED. That's something else to decide. The original Try, the LEDs are just on. They just light when the thing's powered. We've got the option of adding more op amps and having the them driven by the amplitude. I don't necessarily know if I want that or not. To be decided. I'll just keep the LED close by. Okay, orientation. So this is set up as pin 3, 1's going to ground and 2's the taper. So this needs flipped that way. I'll just need to make sure I put the actual fader the same orientation as the original. So the 4 pins are at the top, and then that's going towards pin 3. So I can never remember off the top of my head like which way round it is versus a pot. A pot's easy, it's just 1, 2, 3, and you're turning 2 towards 3, but I can never remember which one's 1 and which one's 2 on what side. Okay, so let's put this down here. It's going to go to a resistor. Let's just put that there just now. A resistor, and that's 0402, and this is 120k for some reason. And I want to triple that for our 3 inputs. Okay, and these are already incremented properly. I'll move these LEDs off to the side because I'll put them somewhere else in the schematic. I mean, if they end up just being the same and just static lighting, then I'll maybe just throw them in here with current resistors on them. Okay, and let's make our mixer. There. So I want the non-inverting on the bottom so I can draw the feedback loop on the top, just because I think that looks neater. Chasing rabbits. Okay, ground the non-inverting, and let's add a feedback resistor. Call that 100k. And then into a 10k resistor, into a 10U electrolytic. So I'm going to keep with electrolytics for these. There's some of the capacitor values I'll find more appropriate parts that will be C0G. So like I was saying earlier with the C0G versus film caps for audio signal path stuff. C-pol. So C polarized. I think that's the exact same footprint that is the 10k the 10 microfarad capacitor that I typically use. I'll check that when we get to creating the PCB from the schematic. That's there, that's polarized. Value. Oh. 10 micro. There we go, we have an input mixer stage. I'm going to quickly run out of room on this schematic, so I'm going to change this to A3. Just make it bigger. Bring this down here. Cool, we've built a mixer. Yeah, I'll just keep it on one big sheet. It's not a huge schematic. Like for bigger, more complicated things, I'll maybe subsheet them. There's even ways of, like, if you draw a single sheet, you can just duplicate that sheet and it'll multiply your circuit.
Right.
And just, you know, means that you don't need to draw everything out individually.
They become kind of sub-modules.
Yeah, yeah. So that's that done. Let's do the control input stage. So that's this section here where we have volt per octave, linear FM, which is attenuatable. Then we've got our coarse pot and fine pot. Not sure why that's got a 680R on it. So this is passive summing, well, active because it's a transistor stage, but there's no op amps. This is a combination of this variable sync resistor, which if we ignore these three and just see signal coming here, that's a voltage divider. So that's R1 into R2, which is going to ground, and that's giving us a ratio that divides down the voltage amplitude. But that being variable, it's a calibration point for scaling this input range as part of the volt per octave tracking. But then there's this as a positive bias at that stage between these two transistors. So it's a bit of a bodge, but it's, you know, it lets you calibrate the volt per octave tracking. Close enough. I mean, it's not the, you can maybe get like an octave or two of convincing tracking, but it's more, it's a vintage circuit, so it's more looking for just key tracking type ranges. So let's add in another jack. Let's call this one for octave. For that we've got linear FM. And then we have two pots. So pots, we're going to go with, these ones are actual pots, so it's not, this will be that one, which is the attenuator over the FM input, and then coarse and fine. And these are all three are D shaft pots. So this is rotary, and that's the top one there, pot D shaft. Because I've got slight different footprint versions for the D shaft pot versus the tall trimmer pots that we use. And that's because there are slight differences in that pink outline. So that's the courtyard. So that's basically the safe to place within, or unsafe to place within line. So pots D shaft 9mm. So that's the main one that I use. The tall trimmer 9mm is slightly different shaped, just because the actual tall trimmer versus D shaft. So it's the same physical footprint, but the mounting pegs are slightly different shaped. Yeah, like that's plastic surrounded by a folded metal, whereas this is more of a single metal piece. So yeah, the courtyards fit slightly differently with it. So we'll keep with that one. And I assume this will be 3 at the top. Yeah, pin 3. Let's do that. That's interesting. I do remember there being some quirk with the tràigh that if you patch in or out, I think maybe to volt per octave, like there's sometimes a noticeable
like jump or dip.
pitch. Yeah, and that's probably because I don't have the normal connected, so that it's floating, so that's I'll maybe add like a 0 ohm jumper resistor or a solder bridge so that I can choose at the hardware assembly stage whether I want those connected or not. Let's just do that now. Jumper. Let's go bridged. No, that's I want a surface mount one. Solder jumper. Bridged. Let's go with that one.
So that's just 2 pads really close together that can be bridged with solder.
Exactly, yeah. Although it's this version is bridged by default, so I'll need to cut them if I don't want them. Which I'm pretty sure this is what I'll want, but makes it a bit easier to cut that, because otherwise I would need to drill out the normal pinhole, but after desoldering the jack, so this way it's modifiable after the fact.
Yeah.
Easier, and I can just throw that on the back of the jack footprint. So that's volt per octave, that. So 2 pots, and that's 2 of these.
That's pretty useful in prototyping, having that as an option.
Yep. Let's add resistor in. I'll copy it exactly. Although that's a 0 ohm jumper, so I don't actually need anything there. This one's 680R for some reason.
Switch seat. I'll take this microphone off first.
You're not wireless. I've done that a few times in the studio.